didn't realize this was going to be a debugging room. So that works because I do have a story to tell here. And a lot of this is, I was coming from like what I would call like normal observability. And I have to say that because I forget who said it at the beginning of the show today, that basically dev is research is a prod in GenAI. Like they're all the same thing. So people are coming from different angles, ML or dev or research backgrounds. And at the end of the day, we want to be able to use systems that are reliable, and I'm going to go for a laptop-centric approach. So if you're getting started with code that uses these things, and because it's been mentioned so many times and there's not that many minutes here, we know there are issues, and a lot of people talk about things that are different between traditional software and GenAI-based ones. And so we have more interesting black boxes. We'd like to know what's going on in them, but we also need to develop systems that flex with that reality. So I'm coming at this from a sort of like, how do you work with this stuff? Like, how do you work with the code? How do you work with the LLMs? How do you relate it to other software? Because at the end of the day, it's mostly similar to any given software architecture. It's just that once you get to the inference down, it gets very interesting. But everything around that is very similar to normal web services. So to put it like this, OpenAI or any of the friends out there is at the end of the day accessed by your software just like a web service, right? It's literally a web service. Now, when you get into any of the real-time APIs, they are complicated web services, but they're still web services. So when engineers get bewildered by GenAI terms, you can say, calm down, it's just a web service, like move along. And that also, like, people forget the programming languages are used sometimes. Like OpenAI's command line interface is just a wrapper over their Python SDK. And so when you know how things are composed, it can reduce the fear. My app, because I always want to like focus on the stuff around it versus what it's actually doing, just saying, okay, what ocean contains Bouvet Island? I wanted something interesting enough that some of the LLMs would give a wrong answer just to do that. And the main idea here is that if you're starting with your laptop and you find that things go bump, that's a normal thing, because like I try to tell some of my software engineering friends, the cadence of AI is generally about 3 weeks. So if you're not experiencing some unexpected change in 3 weeks, you probably missed something. Upgrade, and then it'll break for you. And so while the APIs are becoming more reliable, they still are making changes that could be surprising to you. Because, for example, a couple of months ago, OpenAI announced the response as a stateful API, which can still be done in a stateless way. But some libraries started flipping that on by default. So especially if people are using proxies, then they don't support that API, and all of a sudden things break. So what I find pretty helpful frequently is to be able to see the raw HTTP requests. And there's one you can just put on your laptop really easily, mitmproxy, and see. And even though you're talking about authenticated services, they have a built-in thing to like give you a snake oil certificate so that you can just make believe everything's secure and see your requests go back and forth. Something I'm a little bit like, I get nervous about technology because like the last presentation ended that the most important eval metric is instruction following, right? A lot of things are implemented as instructions. Guardrails are implemented as instructions. Sometimes containerization is implemented as instructions. If it doesn't follow any instructions, then is it really guarding anything? And so like I don't like putting like all of my credentials in like a .env file in my code space that my AI coding assistant is going to access, because maybe it won't follow the instructions to ignore that file. So like I put like you can use Light LLM, you could use any of the AI gateways and schlep your config in there, and that way you can get an authenticated endpoint to your inference. I find that helpful too. OTel or OpenTelemetry was mentioned before. Yeah, you use that in systems, but you can also use that in your laptop. Actually, I use the one OTel 2e, which is a terminal UI made by a Japanese engineer in his free time. And you don't have to have like an online system. And so there's plenty of ways to look at your traces, not just in big systems. And this is just a screenshot of MidMweb, which if you can't read it, it's showing that like as I was intercepting, it took 2 of my chat completions, one from OpenAI itself and another one from my Ollama server, which is just a laptop driven model server. And then I could see all the headers, and you can just literally hit the edit button and hit replay. So if your like your Python library was making some weird garbage and you could figure out what went wrong, you could just monkey around in here and then file the bug with whatever the library is saying, okay, well, it did this, but it should do that. And that's really important for any of these AI libraries. I've raised like, I don't know how many 100 bugs in various libraries. And as long as you can give something for someone to repeat, then they or their coding assistant can have a chance of fixing the bug. So that's one of the reasons why this stuff is helpful in development. Integration tests, you get to like very hairy world very quickly because of the fact that LLM responses aren't that predictable, even if you do temperature 0, et cetera, unless you're doing a demo. Like I did a demo yesterday or a couple of days ago, and the LLM kept repeating exactly the same answer. And I'm like, why? I made this intentionally. And in fact, my code that accompanies these slides, I had to switch it to reruns equals 5 because somehow it just kept flaking until the 5th one. But this is like the poor man's way to know that your code is working end to end, but not talking about quality. All it means is that your calls are going out, and if you're in Python, you can put a marker there to make sure it's a heavy test, doesn't run that often, and then you can use interesting things like capsys, which will allow you to like intercept standard I/O, so you can even test if you're spitting out bad logs and things. Another approach is that, especially if you're working in shared code bases where not everybody has access to a specific inference cloud, I find this very normal with ones like Azure OpenAI, where like not everybody has a key to that or whatever, or Bedrock. And so you don't necessarily want everyone to have to like run that edge path, but you can use this thing called VCR, which was originally a Ruby library, I believe. It was ported to Python. If you're using Node.js, you can use a knock for recording of HTTP requests instead of that. But basically what it would do is it will create a directory, and then if the request to the web service, and that could be Arize itself, actually I have one for that, for Phoenix or OpenAI, if the API changes, then it will taint. So that way you'll know that like the library is now behaving differently than it did before. And this is what I do to like lock in my knowledge. Like I knew this passed once, and and then you look at the request difference, and then maybe it's using a different endpoint now. So then you know where to start, and this is from the code base. So I think online offline is a very interesting jargon that we have, because like online sometimes is batch job, but let's just say we kind of agree what offline is. It's not online, but anyway. And I like to use unit test runners to play with evals, just because I like that they already do formatting, they already do matrices for you and all this other stuff. I know people have their own styles, but I particularly like just throwing that in a unit test runner. And so Phoenix has an eval library, which has a bunch of stuff like normal question answer, relevancy, hallucinations. And then there's talk about like evaluation, about how maybe you would want to write your own metrics. So I did error analysis of this question about Bouvet Island, and there was like a number of error patterns that you'd expect. One, made up oceans. Another one that could pass the other test, which is interesting. So it says like, what ocean is Bouvet Island in? And it will say an ocean. And well, you're not wrong. And the other metrics will just be happy with that. But you'd have to like write an answer, or not using like the right ocean names, because like not everybody has the same one, or marking Southern Atlantic wrong. So this is a toy thing, but this is a sort of like a real error analysis you would go through, and you would know your error patterns, and then you try to make sure that those are locked in, because otherwise it's just like, okay, 72% hallucination, great. This will give you a way to interpret the others. Now, obviously Phoenix is an eval platform, and so they have instructions on how to like take a batch job and just cycle through all your traces and see which ones are missing, your evals, and then you can backfill them. Of course, you can put in thumbs up, thumbs down human signals using the annotation API, and then you can like combine all these little gauges as your own like kind of idea of health, and that's pretty interesting. And then I work at Elastic. It's an OpenTelemetry based system with logs and everything else in there. And one thing that's interesting that some people may forget, because like it's not so much in your face, but Arize Phoenix is basically using OpenTelemetry traces as how everything's stored at the end of the day. Like these are attachments to traces, and the instrumentation is OpenTelemetry and all this other stuff. So if you have a collector, like Elastic's one's called E dot, you don't pronounce it E dot. Anyway, and so basically logs, metrics, and traces could go through whatever the system is that you're already using. Like, so if you're using Elastic, it would be to Elasticsearch. But any of the things that are called collector also have the ability to shove them somewhere else. So you could actually have a collector that can go to like your existing system with all the other stuff, and then schlep your traces over to Phoenix, which will allow you to see the same trace in two systems. Obviously, one's not going to be able to read the bespoke information, because user feedback, annotations, evals, those are signal types that are not defined in OpenTelemetry, and they probably won't be for a while. But that's no problem, because at least this part is a good intersection, and the trace ID is the most important part of it. So in this way, you could actually like see it two ways, right? And so in this case, maybe if you're using a normal observability platform, you've got like all the rest of your logs, you can do your queries and everything. And then unfortunately, you're hopping UIs, but actually it's not that big of a deal because it's a specialized UI. And so you'd be able to do that. So it's just an interesting idea. And if you want to scan that, it will definitely take all your Bitcoins and then send you to this. This repo here has all the stuff that I talked about. I don't do presentations on things that I don't work on myself. So you can play with it if you want and fix my Python, because I'm not that good at Python. But at any rate, I hope this was an interesting perspective from the laptop up about like how you might end up walking to Arize one day.
Awesome. Thanks, Adrian. Appreciate it. Are there any questions? We do have a minute or two for questions.
Yeah, I'm good.
Thank you for the presentation. It was great. I have a question. Hopefully it's not too naive, but is there a way that this log could be used for, like, I'm thinking about the SPY or something similar that can improve the prompt and eval at the log, or no, it's like too far off?
No, actually, I think a lot of eval platforms will have like basically either integrations into the data set management or otherwise. And whether it's talked about as a log or a span or any other type of time-stamped event, yeah, that's pretty much what you would expect. And so, yes, is the answer.
Any other questions?
Is there support for redacting like PII information? Because if you're putting this in production and a lot of prompts and conversations contain PII and sensitive information, is that like, have you guys thought about any sort of redaction or something like that?
Yeah, I mean, there's a questions about redaction. Yeah, so I mean, I think that in some cases, some filters like guardrail type of products will have redaction capabilities, whether they kick the answer out or like I think we've all seen some famous moments where something like starts to say something and then backtrack. But I would probably classify that in the guardrails part of the architecture to like make sure it doesn't go back, because I think the evals would be centered on like faithfulness, and then there's evals about jailbreaks and things, which could be like what you would want to redact because it's accidentally leaked some information or something like that. But I would say that will that will fall into guardrails. I'm trying to remember who, but maybe it was Confluent. One of them has like some very interesting system of basically secret key architecture where it would basically put ciphertext in as placeholders, which then they could reverse if it gets to a certain spot. So I think redaction is one of those areas where you can probably find infinitely complex solutions. But I think that from an applicable standpoint, it's probably likely to be in these proxies in the guardrails area.